All right, Gen Chem kids, we are going to learn how to do stoichiometry today. Now, stoichiometry, it's a word that sounds really scary and kind of awful, but it really is a Greek/German, really old Greek, and brought into German about 200 years ago. It's the study of the quantitative relationship between products formed in a chemical reaction. So basically, if I start off with 20 grams of this, how many grams of that will I make in a chemical reaction? So we're using the mass to mole conversions as well as the balanced chemical reaction ratios to do all of this. And let's see how this goes. So stoichiometry is basically it's based on the law of conservation of mass. So the amount of mass that goes into making something or into a chemical reaction is going to be the total mass of what comes out. It may be rearranged, it may be gases, liquids, or solids, or whatever, but the mass into a reaction is always equal to the mass out of a reaction. Okay? So recall that this law states that matter is neither created nor destroyed in a chemical reaction. So in any chemical reaction, the amount of matter present, the mass of it, is going to be equal as the mass that comes out of that reaction. So therefore, the mass of the reactants is always going to equal the mass of the products. So we're going to use that law of conservation of mass to do the mathematical relationships between grams in and grams out. Okay, so the very first thing that we always do when we do stoichiometry is we balance the equation first. That is rule number one, always balance the equation. So, because most of the time when you're given an equation, it's really just what we call a skeleton equation like this. This equation is just a skeleton. It doesn't have any coefficients. So we need to balance it. So let's look at iron first. So here I have 1 iron, here I have 2. So I'm going to double that up. And then I have 2 oxygens and I have 3 oxygens here. So my least common multiple between 2 and 3 is 6. So I'm going to multiply my O2 by 3 to get 6 oxygen atoms, and I'm going to multiply my iron oxide by 2 to get 6 oxygen atoms. This also then multiplies my iron that I've already thought I did. 2 times 2 gives me 4 irons. So 4 times 1, right, because I have 1 iron atom here, I'm going to have to multiply that by 4 instead of 2. Okay, so there's my balance. So I want you to think about this. These coefficients that we put in, the 4 in front of the iron, the 3 in front of the oxygen, and the 2 in front of the iron oxide, what do those coefficients really mean? What do they represent? Think about it for a minute. Okay, hopefully you thought of one of 2 things. Those coefficients represent an atom or a molecule ratio. So for example, every 4 atoms of iron that I start with, if I have all the oxygen in the world, I will end up with 2 molecules of iron 3 oxide. Or for every 3 molecules of oxygen that I start with, if I have all the iron in the world, I'll end up with 2 molecules of iron 3 oxide. So we can think of this as an atom or a mole ratio, but couldn't we also look at this as, an atom or a molecule ratio? Couldn't we also look at this as a mole ratio? If I have 4 moles of iron, I could end up with 2 moles of iron 3 oxide. So this could also be looked at as a mole ratio. Okay, both of these things are correct. So for stoichiometry, we are really going to look at these coefficients that we put in as mole ratios. If I have so many moles of this, how many moles of that will I be able to make? Okay, So we're going to use this with our skills of unit analysis to help us do the math. Okay? Wow, what happened to my page? It just kind of flipped back. So let's scroll to where we were. That was kind of odd. Okay, so we're going to use this equation to figure out this next problem. If I have 4 moles of iron, why did it just do that? Wow, why is that doing that? Okay, we'll try this again. If I have 4 moles of iron and unlimited oxygen, how much iron trioxide can I produce? So, what we have to do is we have to look at the coefficients between the two things that it's asking about. It is asking about iron and oxygen. So we are going to look at the coefficients of iron and oxygen. So we're going to grab the 4 and we're going to grab the 3 right here. Okay? So we're going to always start with the number that is given. Okay? So that means we have a ratio from our balanced chemical equation that we just grabbed out of that equation of 4 moles of iron to it's asking about, back up. It's not asking about oxygen, it's asking about iron trioxide. So I don't want to look at my moles of oxygen. This is why it pays to really read the question, which I did not do. So let's put a 3 in here. Let's grab this again. Right there. Okay, so for every 4 moles of iron I have 2 moles of iron trioxide. So that's my ratio. We are going to be pulling ratios out of the balanced equations all the time. And by doing that, we're just really pulling the coefficients out of that balanced equation like I just did. Okay? So let's do the math. So we're starting with 4 moles of iron. I want my moles of iron to cancel. So I'm going to grab the moles of iron from the equation right here. I have 4 moles of iron showing up in my equation. And I want to go to iron trioxide. So I'm going to grab the iron trioxide moles. I have about 2 of them. 2 moles of iron trioxide. Okay? Now, in mathematics, if I have something divided by the same thing, that if it's a number, it reduces. If it's a unit, it cancels. So because these are units, they absolutely cancel. So the numbers are really just left. So remember, everything on the top is a multiplier. And everything on the bottom is a divider. So I'm going to take this 4 multiplied by the 2, which gives me 8, divided by 4. 8 divided by 4 is 2. So I'm going to be able to make 2 moles of iron trioxide with the 4 moles of iron that I started off with. Now you probably could already do that in your head because the ratio we already started with 4 moles of iron. Okay? So let's look at another example. What if I had 6 moles of oxygen and unlimited iron how much iron 3 oxide could I make? So this time we are comparing oxygen. So let's grab another color. This time we are comparing oxygen with iron 3 oxide. So I'm going to grab those coefficients. So my oxygen coefficient and my iron 3 oxide coefficient, I'm going to grab those coefficients. So that means I have a ratio of 3 moles of oxygen to 2 moles of iron 3 oxide. So it's a different ratio because I'm looking at different things in the chemical equation. Okay? So we're going to start with our 6 moles of oxygen. And I want my moles of oxygen to cancel. So in the next step, my moles of oxygen needs to be on the opposite side. So it's going to be on the bottom. So I'm going to grab this from the balanced equation. 3 moles of oxygen can make 2 moles of iron 3 oxide. Okay, once again, everything that is on the top is going to be a divider. Everything on the top is going to be a multiplier. So we're going to take 6 times 2, which will give us 12. And everything on the bottom is going to be a divider. So 6 times 2, 12, divided by 3. 12 divided by 3, what is that? Did you say 4? Yep. So I would be able to make 4 moles of iron 3 oxide. Notice my moles of oxygen are canceled out. So the only mole unit that I have left is iron 3 oxide. So that's what I've got. Okay? The important, and I'm hoping obvious point of this example is that when we use our coefficients, the coefficients in the balanced equation tell us the mole ratio. Okay, so we use those coefficients. Oh boy, that didn't switch over fast enough, did it? They tell us our mole ratio. Okay, this is the most important concept of Stoich. Okay, so I'm going to draw around this box to kind of highlight it. This is the concept of stoichiometry. We take those coefficients from the balanced chemical equation and we use those coefficients to give us a mole ratio that we can change from one compound or molecule to another within that balanced equation to figure out a relationship between what's coming and going in a reaction. Okay? So we're going to try a few more that are related to this equation that we've already done a lot with. Okay? So, how many moles of iron would be required to react with 6 moles of oxygen? So once again, we are looking at 2 different things. We're looking at our relationship between iron and oxygen. So we want to grab our coefficients of iron and oxygen in that balanced equation. So let's look at our coefficients. So iron, we have 4, and oxygen, we have 3. Okay? So I'm going to just put that down really quick. So for iron, we have a coefficient of 4, and for oxygen, we have a coefficient of 3. Okay? So let's start with our number that's given. We have 6 moles of oxygen. And I want to know how that relates to iron. So I'm going to use my ratio from my balanced equation. I want my moles of oxygen to cancel. So my moles of oxygen are going to be on the bottom of the next step. So I'm going to grab that coefficient from the balanced equation. 3 moles of oxygen react with 4 moles of iron. Okay, notice those come from the equation. Notice my moles of oxygen are divided by moles of oxygen. So the unit I have left is moles of iron, which is what I want, right? Okay, All the numbers on top are multipliers. So 6 times 4 is 24. And the numbers on the bottom are the dividers. So 24 on top, 6 times 4, 24, divided by 3. 24 divided by 3 is 8. So I would be able to I would need 8 moles of oxygen. I would need 8 moles of oxygen to make that reaction happen. Okay? So this next one is how many moles of iron and oxygen would be required to produce 8 moles of iron 3 oxide? So let's grab the coefficients. We already have the coefficients for oxygen and iron already because we've done this. So our coefficient for iron is 4, and our coefficient for oxygen is 3. Let's go back up to our equation and look at our coefficient for the iron 3 oxide again. So if we look at our coefficient for the iron 3 oxide, we have a 2. So we're going to put a 2 here to remind us of that coefficient. Okay? So I'm going to look at the relationship between iron and the iron 3 oxide first. Okay? So here we go. I've got 8 moles of the iron 3 oxide. And I want to know moles of iron. So I'm going to put my moles of iron 3 oxide on the bottom so that I can cancel it out, and put my moles of iron on the top so I can know about that. So I'm going to grab that 2 moles of iron 3 oxide, react from 4 moles of iron. Okay, so my moles of iron 3 oxide cancel out, and I'm left with moles of iron, which is what I want. Okay, all the numbers on top are multipliers, so 8 times 4 is 32, divided by the numbers on the bottom, which is 2, so 32 divided by 2 is 16. So I would need to start out with 16 moles of iron to get that 8 moles of iron 3 oxide. Now let's look about the oxygen. How much would we need of oxygen? So once again, I'm going to start with the 8 moles of the iron 3 oxide. And I want to get my moles of iron 3 oxide to cancel, so I'm going to put the relationship from the balanced equation. 2 moles of iron 3 oxide react with 3 moles of oxygen, or from 3 moles of oxygen. Okay? My moles of iron 3 oxide cancel out. I'm left with moles of oxygen for my unit, which is what I want to know. Okay, top numbers multiply, bottom numbers divide. So 8 times 3 is 24, our top numbers, divided by 2, our bottom number. Let's see, 24 divided by 2 gives us 12 moles of oxygen. So we would need to start off that reaction with 12 moles of iron 16 moles of iron and 12 moles of oxygen. Okay? So by now, hopefully you can see that I can use these mole relationships from the balanced chemical equation to help me understand if I start off with this much, I'm going to make this much. Or if I want to make this much, I need to start off with this much. We can do it either way. And it's a way that we can relate whatever is in that chemical problem, whatever is in that chemical equation, to whatever else is in that chemical equation. It's a really, really strong mathematical tool. All right? So we can actually do this grams to moles, moles to grams. Okay, so here we go. Let's do another reaction. If I have 4.83 moles of bromine and it reacts with excess sodium, how many moles of sodium bromide will be formed according to this equation below? Okay, so the very first thing we've got to do is we've got to balance this chemical equation. Okay, so let's balance this chemical equation. So I've got 1 sodium and I've got 1 sodium. I'm okay so far. I've got 2 bromines and I've got 1 bromine. So I'm going to double this, which means I need to go back and I need to double my sodiums. Okay? Are we okay with that balance? 2 sodiums, 2 sodiums, 2 bromines, and 2 bromines. Okay? So the next step, we've got to use our molar relationships to convert the moles of the given substance, which is what we know, right? The 4.83 moles of bromine into sodium bromide. So we're going to compare bromine with sodium bromide. So let's look at this. I want to compare bromine with sodium bromide. So I'm going to grab my coefficient from bromine. And if there isn't a coefficient there, remember a 1 is always implied with my coefficient for sodium bromide. Okay, so I'm going to grab those 2 coefficients from my balanced equation. Okay, now I'm going to take the number that I'm given with, started, which is the 4.83 moles of bromine. Okay, now I want my moles of bromine to cancel. So on the next step, I'm going to put my moles of bromine on the bottom, which is the opposite side. So I have 1 mole, right? Because a 1 is implied if it's not there. 1 mole of bromine reacting to give me 2 moles of sodium bromide. Okay? So this is what I'm asking for. My moles of bromine cancel. Okay? So I'm left with moles of sodium bromide, which is what I want. So mathematically, everything on the top is going to be multiplied. So 4.83 times 2, and then we're going to divide by 1. But everything divided by 1 is just the same thing, right? So 4.83 times 2. Let's grab our calculator. I think this will be 9.66, but I just want to make sure. 4.83 times 2, yep, 9.66. Oh, wow. 9.66 moles of sodium bromide are what I can make. All right? So notice I grabbed the coefficients right from the balanced equation to create the ratio that I needed to create to compare the 2 things that I wanted to compare from the question. All right? Next time, we are going to talk about how to go from grams to moles and then convert the moles from the ratio in the balanced equation and go back to grams. So this is what Stoich really, when it's fully powered, is. We start off with the grams of our known thing. We convert it into moles of our known thing. Then we convert it using our mole ratio to moles of the stuff that we want to know about or our unknown. And then we go back to grams of our unknown. And I will tell you and teach you how to do this next time. Okay? So have a great day. We'll talk to you later. Bye.